For most of human history, dying from aging felt natural, inevitable, almost polite. Our bodies slowly weakened, systems failed one by one, and we learned to accept that decline as the price of being human. But in nature, this story is not universal. Some animals grow older without truly falling apart. Some barely slow down at all. They reproduce, move, and survive long after a human body would have collapsed. The unsettling truth is not that humans age badly, but that aging itself is not a fixed biological rule. It is a path evolution chose for us, and not for others. The real question is not how humans age, but why evolution allowed our bodies to be disposable while preserving longevity elsewhere. Aging feels so obvious to us that it is easy to mistake it for a universal rule of life. We watch our bodies change year after year, strength slowly declining, recovery taking longer, memory becoming less sharp. From childhood, we absorb the idea that living things grow, peak. Because this pattern is so familiar in humans, we quietly assume that it must apply to all living organisms. Yet when we step back and look carefully at life as a whole, this assumption begins to weaken. In biology, aging is not defined simply as the passage of time. It refers to a gradual loss of function that increases the risk of death as years pass. And when scientists examine the natural world through this lens, they find that this pattern is far from universal. Some species follow a curve that looks nothing like ours. In certain animals, the risk of death does not rise with age in the same way. Their bodies do not steadily unravel. Instead, they maintain stable function for most of their lives, declining only near the end, or sometimes not showing a clear decline at all. This immediately challenges the idea that aging is an unavoidable consequence of being alive. To understand why this matters for humans, we must return to the earliest conditions in which our ancestors evolved. For most of human existence, survival was uncertain and short-term. Injury, infection, predation, and scarcity shaped daily life. Under such conditions, there was little evolutionary pressure to maintain bodies for many decades beyond reproduction. Natural selection favors traits that increase the chances of passing genes to the next generation, not traits that ensure comfort or durability in old age. In this context, aging is not something that evolution actively created. It is something that was largely ignored. If a biological system functions well enough to survive, reproduce, and raise offspring, there is no strong selective force to keep repairing it indefinitely. Over time, small inefficiencies accumulate. Cellular damage builds. Maintenance systems operate just well enough, not perfectly. What we experience as aging may simply be the visible result of this long-term neglect. Importantly, this neglect is not universal across species. Different environments produce different evolutionary priorities. Some animals evolved under conditions where long-term stability mattered more than rapid reproduction. Others faced ecological pressures that rewarded efficient repair and sustained function. These differences did not arise from conscious design, but from countless small variations filtered through survival and reproduction. Humans emerged from a lineage shaped by movement, adaptability, and social cooperation, not by biological permanence. Our bodies are flexible, responsive, and capable of remarkable short-term resilience, but they are not built for indefinite maintenance. When we recognize this, aging begins to look less like a destiny written into life itself and more like a specific outcome of our evolutionary history. Instead, it places it within a broader biological context. It reminds us that our experience is not the standard by which all life must be measured. Aging, as we know it, is one solution among many, shaped by the ancient conditions that formed our species long before concepts like longevity, medicine, or extended old age ever existed. Aging becomes easier to misunderstand when we confuse it with time itself. Every living thing exists in time, but not every living thing deteriorates because of it. In biology, aging is not simply getting older. It is a measurable increase in the risk of death as time passes, caused by a gradual decline in the body's ability to maintain itself. This distinction matters because many species live for long periods without showing the same rising vulnerability that humans experience. Some organisms age slowly, some age in unusual ways, and some appear to age so little that their chances of dying remain relatively stable for most of their lives. When researchers study mortality patterns across species, they find that human aging represents only one possible trajectory, not the default pattern of life. To see why this matters, we must again return to the conditions under which early humans lived. For most of our evolutionary history, reaching old age was rare, not because aging was aggressive, but because survival itself was uncertain. Accidents, infections, and environmental threats ended lives long before long-term biological decline became relevant. Under these conditions, the human body was shaped to perform well early. Aging, in this sense, is what happens when a biological system optimized for short-term success continues operating beyond the time frame it was refined for. This helps explain an important difference between lifespan and aging. Lifespan refers to how long an organism can live under ideal conditions. Aging describes how quickly its internal systems lose reliability over time. Humans can live many decades, but the reliability of our bodies decreases steadily after early adulthood. Other species may live shorter lives but experience less internal decline during that time. In some cases, reproduction and survival remain stable almost until death. This challenges the idea that living longer automatically means aging more slowly. It also challenges the assumption that evolution aims to maximize lifespan. Evolution favors efficiency within a specific ecological context. If a body performs well enough to reproduce and support offspring, there is little evolutionary incentive to invest energy in long-term maintenance. Repair mechanisms are costly. They require resources that could otherwise support growth or reproduction. In humans, these trade-offs were shaped by a life defined by movement, adaptability, and social cooperation, not by biological durability. Our ancestors benefited from bodies that healed quickly, learned rapidly, and responded flexibly to changing environments. Long-term cellular perfection was not required. Over time, this produced a species capable of surviving diverse conditions, but vulnerable to cumulative damage. This vulnerability becomes visible only when survival improves, when medicine, shelter, and stable food supplies allow bodies to reach ages that were once uncommon. At that point, aging reveals itself not as a new problem, but as an old limitation finally exposed. Importantly, this limitation is not shared equally across life. Species that evolved under stable conditions, low predation, or slow reproductive cycles often display different aging patterns. Their bodies invest more heavily in maintenance because survival over long periods directly affects reproductive success. Humans did not evolve under such conditions. Our evolutionary success came from adaptability, learning, and cooperation across generations, not from biological immortality. Aging, therefore, is not a failure of the human body. It is a reflection of the priorities that shaped it. By understanding aging as a trade-off rather than a flaw, we begin to see why humans die from aging while some animals do not, and why this difference emerged long before modern humans ever began to question it. Humans often assume that what feels normal to us must be normal for life itself. Because every human we know ages, weakens, and eventually dies, we quietly treat this experience as the biological standard. Yet this assumption is not based on evidence. It is based on familiarity. From an evolutionary perspective, humans are a single, very specific experiment shaped by particular pressures and constraints. When we project our own aging process onto all living organisms, we mistake a local outcome for a universal rule. Biology, however, does not operate by human intuition. It operates by survival, reproduction, and trade-offs made under specific conditions. Once we step outside the human frame, aging begins to look less inevitable and more conditional. Many species do not experience a steady increase in vulnerability as they grow older. Their survival curves remain flat for much of their lives. Death comes not because systems gradually fail, but because of external events or sudden breakdowns late in life. This difference is not mysterious. It reflects how natural selection shaped bodies in response to their environments. Humans evolved in settings where flexibility, learning, and cooperation mattered more than long-term bodily preservation. We survived by moving, adapting, and sharing knowledge, not by maintaining perfect cellular repair over many decades. As a result, our bodies prioritize short-term function over long-term stability. This prioritization made sense for early humans. It allowed quick growth, early reproduction, and resilience in harsh environments. Aging appears later as a consequence of this strategy, not as its goal. The problem arises when modern humans forget this origin. We live in environments radically different from those that shaped our biology. Medicine reduces early death. Food is more reliable. Physical danger is lower. As a result, many people now live long enough for the hidden weaknesses of the human body to become visible. We interpret these weaknesses as failures, as if something has gone wrong. In reality, nothing has changed in our biology. What has changed is the context. Our bodies are doing exactly what they were shaped to do. They are simply operating far beyond the time frame for which they were optimized. When compared to animals that evolved under different pressures, this contrast becomes clear. Species with low predation, stable habitats, or slow life histories often invest more energy in long-term maintenance. For them, survival across many years directly affects reproductive success. For humans, reproduction was largely front-loaded into early adulthood, long before aging became relevant. This is why some animals appear to escape aging, while humans do not. It is not because they possess secret advantages or superior designs. It is because evolution asked different things of them. Humans paid a price for adaptability, intelligence, and social complexity. That price was a body that performs exceptionally well early, but accumulates damage over time. Understanding this helps dissolve the idea that human aging is a universal biological destiny. It is a historical outcome, shaped by ancient environments and priorities that no longer exist. By recognizing this, we stop treating our own experience as the center of biology. We begin to see aging not as a mistake written into life, but as a consequence of the particular path our species took. This perspective does not solve the problem of aging, but it places it where it belongs, within the long story of human origins, rather than as an unchangeable law of nature. Evolution is often misunderstood as a force that plans, designs, or aims for improvement. In reality, evolution has no foresight and no concern for the future comfort of a species. It works through immediate outcomes. Traits that help an organism survive long enough to reproduce tend to persist. Traits that do not are gradually removed. Everything else is secondary. When we apply this simple principle to human aging, an uncomfortable realization appears. For most of our evolutionary history, there was no reason for natural selection to favor long life. What mattered was surviving childhood, reaching reproductive age, and raising offspring until they could survive on their own. Once that threshold was crossed, additional years offered little evolutionary advantage. Early humans lived in environments filled with constant risk. Injury, infection, exposure, and starvation were common. Under these conditions, the probability of dying from external causes was high at every age. Very few individuals lived long enough for slow internal deterioration to become a dominant threat. As a result, there was no consistent pressure to refine long-term maintenance systems in the human body. Evolution did not need humans to live long. It needed them to live long enough. This distinction is critical. Longevity beyond reproduction does not automatically increase the number of descendants. If most individuals die from accidents or disease in early or middle adulthood, Investing energy in bodies that can function perfectly into old age offers little return. Energy spent on long-term repair could instead be used for growth, mobility, immune response, or reproduction. Over many generations, these trade-offs shape the body toward what is sufficient, not what is ideal. Our bodies are robust in early life. Wounds heal quickly. Muscles adapt efficiently. The immune system responds aggressively. These features support survival and reproduction in unpredictable environments. But they come at a cost. Repair mechanisms are not flawless. Cellular damage accumulates slowly. Systems that work well early are not optimized to last indefinitely. This is not because evolution failed to finish its work. It is because evolution never had a reason to do so. Aging emerges as a byproduct of this process. It is what happens when a system designed for short to medium-term performance continues operating far beyond the period that shaped it. Importantly, this does not mean that evolution selected for aging. Aging was not chosen. It was tolerated. As long as it did not interfere with reproduction, it remained invisible to natural selection. Only in modern times, when external causes of death are reduced, does aging become the primary reason humans die. This shift can create the illusion that aging is a new problem. In truth, it is an old limitation that was rarely exposed in the past. When we compare humans to animals that live longer or age more slowly, the same logic applies. Species that face lower external mortality, or whose reproduction depends on long-term survival, experience different selective pressures. In those cases, maintaining the body over many years directly improves reproductive success. For humans, that link was weak for most of our history. Survival depended more on flexibility, cooperation, and early reproduction than on durability. Understanding this reframes the question of why humans die from aging. It is not because our bodies are poorly made. It is because they were shaped for a world where long life was not required. Evolution solved the problems it faced, not the ones we face today. Aging is the shadow left behind by those ancient solutions, becoming visible only when the environment changes enough to let us see it. For most of human evolutionary history, old age was not a distinct stage of life. It existed, but only rarely, and never long enough to shape the biology of the species. When we imagine the past through modern eyes, it is easy to picture ancient humans growing old in the way we do today. This image is misleading. Life for early humans was dominated by immediate dangers. Childhood mortality was high. Adolescence was uncertain. Adulthood was physically demanding and often short. Under such conditions, reaching an advanced age was an exception, not an expectation. Because evolution responds to patterns that occur repeatedly across generations, rare events have little influence. Old age, for most of human history, was too uncommon to matter. This has important consequences for how aging developed in our species. Natural selection cannot prepare a body for challenges it almost never encounters. If only a small fraction of individuals survive long enough to experience slow internal decline, then the traits that would protect against that decline are weakly favored or not favored at all. Instead, selection focuses on what matters most often. For early humans, this meant surviving infancy, reaching reproductive maturity, and maintaining enough strength and cognition to raise children. Once those tasks were completed, additional years did not significantly increase genetic success. As a result, the human body was shaped to perform well in the first half of life, not to remain stable indefinitely. Aging remained hidden behind more immediate causes of death. Injury, infection, childbirth complications, and environmental stresses ended lives long before cellular damage could accumulate to dangerous levels. In this context, aging was not absent. The body aged slowly in the background, rarely becoming the primary cause of death. Because of this, evolution had no clear signal to respond to. There was no consistent pressure to refine long-term maintenance systems, improve DNA repair beyond a basic level, or eliminate slow-developing weaknesses. These issues simply did not affect reproductive outcomes often enough. The concept of a long, extended old age is a modern development. Improvements in tools, social cooperation, shelter, and eventually medicine allowed more people to survive into later decades of life. Only then did aging move from the margins to the center of human mortality. What we now experience as the dominant cause of death was once a minor background process. This shift can distort our understanding. We may assume that aging is the enemy that evolution failed to defeat. In reality, it was a low-priority issue that rarely influenced survival or reproduction. This explains why the human body appears unprepared for prolonged maintenance. Systems that functioned adequately for early survival were never upgraded for long-term reliability. Joints wear down. Cells accumulate damage. Regulatory processes lose precision. None of this prevented early humans from fulfilling the tasks evolution demanded of them. Therefore, none of it was strongly corrected. When compared to species in which individuals routinely survive for long periods, the contrast becomes clearer. In those species, old age is common enough to matter. In humans, for most of our past, old age remained statistically invisible. Understanding this helps clarify why humans die from aging, while some animals do not. It is not because humans were meant to age poorly, it is because, for the majority of our evolutionary journey, only when circumstances changed did this ancient limitation reveal itself, quietly waiting in a body shaped for a much shorter horizon. It is tempting to think that aging exists because evolution somehow chose it, as if decline were programmed into the human body on purpose. This idea feels intuitive, but it is misleading. Evolution does not actively select for traits that cause harm unless they provide a compensating benefit early in life. In the case of human aging, there is little evidence that deterioration itself was ever favored. Instead, aging appears because evolution failed to prevent it. This distinction is subtle but crucial. There is a difference between being selected and being ignored. Aging belongs to the second category. Natural selection is powerful, but it is also limited. It can only act on traits that influence survival and reproduction in a consistent and noticeable way. Slow processes that unfold late in life often escape its attention. In early human populations, most individuals did not live long enough for gradual internal damage to affect reproductive success. Because of this, the genes and mechanisms responsible for long-term maintenance were never under strong pressure to improve. They were sufficient, not optimal. When a system works well enough to pass genes forward, evolution stops refining it. Anything beyond that is unnecessary from a selective standpoint. Aging, therefore, is not a feature with a purpose. It is the accumulation of small imperfections that were never corrected because they did not matter at the time. This helps explain why human aging feels chaotic rather than orderly. There is no single aging mechanism that switches on. Instead, many systems slowly lose precision. Cells repair DNA less efficiently. Proteins fold with more errors. Inflammatory responses become harder to regulate. They occur because maintaining perfect control over complex systems is costly, and evolution rarely pays that cost unless it brings immediate benefits. In contrast, traits that improve early survival and reproduction are strongly favored, even if they carry hidden long-term costs. Strong immune responses, for example, protect against infection early in life, but can contribute to chronic inflammation later. Rapid growth and high metabolic activity support development and reproduction, but increase wear over time. These are not examples of evolution choosing aging. They are examples of evolution choosing early advantage and tolerating later consequences. When we compare humans to animals that age slowly or appear to avoid aging altogether, the same principle applies. Those species did not evolve anti-aging because aging is bad. They evolved different life strategies in which long-term survival directly affected reproductive success. In such cases, ignoring long-term maintenance would reduce fitness. Selection had a reason to act. For humans, that reason was weak or absent for most of our past. As a result, aging remained an unaddressed background process. Modern humans often frame aging as a failure that science must fix. But from an evolutionary perspective, aging is neither a mistake nor an intention. It is a leftover, a consequence of priorities set long before modern conditions existed. Understanding this reframes the central question. Humans die from aging not because evolution wanted it that way, but because evolution never needed to want anything else. Aging is what happens when life continues beyond the window it was shaped for. Recognizing this does not remove the reality of aging, but it clarifies its origin. It reminds us that our bodies are not broken versions of a better design. They are faithful reflections of an ancient environment in which long life was rare and decline was something evolution could afford to ignore. The human body often feels fragile when viewed across a long lifespan, but this fragility makes sense when we consider what it was originally shaped to do. From an evolutionary perspective, the human body is not a structure built for endurance over many decades. It is a system optimized for short to medium-term survival in unstable environments. Muscles are designed for bursts of activity rather than lifelong strength. Bones balance lightness and mobility against long-term durability. The immune system is aggressive and fast, favoring immediate defense over perfect long-term regulation. These traits allowed early humans to move, hunt, gather, escape danger, and adapt quickly. They were highly effective in the conditions our ancestors faced, but they were never intended to operate flawlessly for 80 or 90 years. The idea of the body as a short-term survival system helps explain why aging affects so many systems at once. When a structure is built for flexibility and speed, it often sacrifices longevity. Human tissues repair themselves efficiently when young, but not endlessly. Cellular replication introduces small errors. Metabolic processes generate damage as a byproduct of energy use. Over time, these effects accumulate. Evolution did not eliminate them because doing so would require costly investments in maintenance that offered little benefit during the years that mattered most. For early humans, survival depended on responding quickly to immediate threats, not on preserving cells for a distant future. This logic is visible in how the human body prioritizes energy. Energy is finite, and organisms must decide how to allocate it. In humans, large amounts of energy are devoted to brain development, reproduction, immune response, and physical activity early in life. Less is reserved for long-term repair and replacement. This trade-off produces a body that performs exceptionally well when young and gradually loses efficiency with time. Aging, in this sense, is not the breakdown of a machine that failed its design. It is the natural consequence of a system that was never designed for indefinite operation. This perspective becomes clearer when we return again to the earliest human environments. Our ancestors lived in landscapes that demanded constant movement and decision-making. Food sources shifted, weather changed unpredictably, social cooperation was essential for survival. Under these conditions, a body that could learn quickly, heal fast, and reproduce early was far more valuable than one that aged slowly but required extensive maintenance. Evolution favored responsiveness over durability. The costs of this choice remained hidden as long as few individuals lived long enough to experience them. Only in modern times, when survival has been extended far beyond ancestral norms, do these costs become obvious. We now ask why joints fail, why organs lose function, why recovery slows. From an evolutionary standpoint, these questions arise only because we are living beyond the horizon that shaped our bodies. The human body continues to function as it always has. It is simply being asked to do so for far longer. Understanding this reframes aging not as a mysterious decline, but as a predictable outcome of a survival strategy that once worked remarkably well. Humans did not evolve bodies meant to last forever. We evolved bodies meant to get us through a dangerous world long enough to pass life on. Aging is the quiet reminder of that origin, emerging only when the world changes and survival outpaces design. To understand the human body as a short-term survival system, we need to look closely at the specific biological trade-offs that shaped it. Every organism must divide its limited energy among competing demands. Energy spent on one function cannot be spent on another. For humans, evolution consistently favored investments that improved early survival and reproduction, even when those investments carried long-term costs. This pattern is visible across nearly every major system in the body. Consider growth and development. Humans grow relatively quickly in early life, especially in terms of brain development. The human brain consumes a remarkable amount of energy, particularly during childhood. This investment supports learning, social awareness, and problem-solving, all of which were essential for survival in complex and changing environments. But high metabolic activity also produces more cellular stress. Faster growth and intense energy use increase the rate at which small forms of damage accumulate. Evolution tolerated this because the benefits of intelligence and adaptability appeared early, while the costs emerged much later. A similar trade-off appears in the immune system. The human immune response is powerful and fast, designed to react aggressively to infection and injury. In environments where wounds and pathogens were constant threats, this was a decisive advantage. A slow or cautious immune system would have been fatal. However, strong immune activity is difficult to regulate perfectly over a lifetime. As years pass, the same mechanisms that once protected the body can contribute to chronic inflammation and tissue damage. From an evolutionary perspective, this is acceptable. Protection early in life mattered more than perfect balance decades later. The musculoskeletal system tells a similar story. Human bones and joints are optimized for mobility and endurance during active years. They allow long-distance walking, climbing, carrying, and fine motor control. To achieve this, they balance strength with lightness. Heavier, thicker bones might last longer, but they would reduce speed and efficiency. Evolution chose movement over durability. Over time, this choice becomes visible as joints wear down and bones lose density. These changes feel like failures only because we expect the body to remain unchanged far beyond the period it was shaped for. At the cellular level, repair systems reflect the same logic. Human cells possess mechanisms to fix DNA damage, remove faulty proteins, and replace worn components. But these systems are not perfect. Absolute precision would require enormous energy investment. Instead, repair is good enough for the years that matter most for reproduction. Small errors accumulate slowly, often without immediate consequence. Only later do they begin to interfere with function. This gradual accumulation is not a flaw that evolution overlooked. It is the predictable outcome of prioritizing efficiency over permanence. When we place these trade-offs back into the context of early human life, they make sense. Our ancestors benefited from bodies that learned quickly, healed rapidly, and responded forcefully to danger. They did not benefit from bodies that remained pristine into advanced age, because few ever reached that stage. It is the long-term cost of strategies that were enormously successful in the short term. Modern humans often interpret these costs as evidence that the body is poorly designed. In reality, the design reflects ancient priorities that no longer match our current conditions. We now live long enough for the compromises built into our biology to reveal themselves. The body is not failing unexpectedly. It is behaving exactly as a short-term survival system does when asked to operate for a long time. Recognizing this helps explain why humans age in ways that some animals do not. Different species made different trade-offs under different pressures. Aging is the quiet consequence of that choice, written into the body long before longevity became common. When the human body is viewed as a whole, aging no longer appears as a series of unrelated failures, but as a coordinated consequence of many small compromises made early in life. Each system in the body was shaped to perform its task efficiently under the conditions our ancestors faced. None of these systems evolved in isolation. They interact constantly, relying on balance rather than perfection. What makes human aging distinctive is not that one system collapses first, but that many systems slowly lose reliability together. This pattern reflects the way the body was assembled through evolution as an integrated survival system rather than a structure built for long-term stability. In early life, this integration works remarkably well. Muscles respond to stress and adapt. The immune system clears infections quickly. Hormonal signals coordinate growth, reproduction, and energy use. The nervous system adjusts behavior based on experience. These systems are tightly coupled, allowing rapid response to environmental challenges. But tight coupling also means that small changes can spread. When repair becomes slightly less efficient in one area, it can place additional strain on others. Minor imbalances that were once easily corrected begin to persist. Over decades, these small shifts accumulate, not because the body suddenly fails, but because it was never required to maintain perfect coordination indefinitely. Returning again to the conditions of early humans helps clarify this process. Our ancestors lived in environments where external pressures dominated survival. Internal decline was slow compared to the speed of injury, disease, or scarcity. As long as the body functioned well enough during the reproductive years, gradual loss of precision posed little immediate risk. Evolution therefore favored systems that were flexible and responsive, even if they were not indefinitely stable. The result is a body that ages across many dimensions at once. Energy regulation becomes less precise. Tissue repair slows. Communication between systems loses clarity. None of these changes alone defines aging, but together they increase vulnerability over time. This explains why aging in humans feels diffuse rather than localized. Aging emerges from the interaction of many systems that were optimized for early success, not long-term maintenance. In species that age slowly or appear to avoid aging, these interactions are organized differently. Their life histories reduce external risk, making long-term internal stability more valuable. Selection in those species favored maintenance across the entire lifespan, not just early performance. Humans followed a different path. Our evolutionary success came from adaptability, intelligence, and social cooperation. The price of this success is paid gradually, across time, as coordination slowly erodes. Modern humans often search for a single cause of aging, hoping to isolate and correct it. This search reflects a misunderstanding of how aging arises. Aging is not a defect that entered the system. It is the natural outcome of how the system was built. Recognizing this does not diminish the value of medical intervention or scientific inquiry. It simply grounds our expectations in reality. The human body is not a machine that has broken down prematurely. It is a system doing exactly what it evolved to do, continuing to operate long after the conditions that shaped it have disappeared. Aging, in this sense, is not a sudden event, but a long echo of our origins, gradually revealing the limits of a body designed for survival, not permanence. When people hear that some animals do not age in the same way humans do, the idea often sounds strange or exaggerated. It can feel as if these species possess something extraordinary, as if they have discovered a secret that humans lack. In reality, the difference is less mysterious and far more grounded in evolutionary context. These animals are not exceptions to biology. They are products of different life histories, shaped by pressures that made long-term stability more valuable than short-term performance. To understand why some animals escape aging, we must first let go of the assumption that aging follows a single pattern across life. In nature, there is no universal aging curve. Different species show dramatically different relationships between age and risk of death. In humans, the risk of dying increases steadily after early adulthood. In some animals, however, this risk remains relatively constant for much of life. They do not become progressively more fragile year by year. Their bodies maintain function until a late and often abrupt decline. It means that the processes that drive gradual deterioration are weaker, slower, or more effectively controlled. The key reason for this difference lies in how natural selection operates over time. In species where individuals routinely survive for long periods, survival at older ages directly influences reproductive success. If an animal continues reproducing or supporting offspring over many years, then maintaining bodily function becomes important. Under these conditions, evolution can see the effects of long-term decline and respond to them. Repair mechanisms are strengthened, damage control becomes more efficient, stability is favored. Many of the animals that show slow or negligible aging evolved in environments with low external mortality. Predation is limited, resources are stable, life moves at a slower pace. In such settings, dying from accidents or sudden threats is less common. This shifts the balance of selective pressure. Internal maintenance matters more because individuals are likely to live long enough for internal decline to affect survival and reproduction. In contrast, early humans faced constant external risk. Under those conditions, investing heavily in long-term maintenance offered little advantage. The difference is not intelligence, complexity, or luck. It is context. Some animals evolved under conditions where patience paid off. Humans did not. This explains why animals that age slowly often share certain life history traits. They tend to grow slowly, reproduce later, and invest heavily in maintenance. Their bodies operate at a more conservative pace. Energy is allocated toward repair rather than rapid performance. Humans followed the opposite strategy. We grow relatively quickly, reproduce earlier, and allocate energy toward brain development, mobility, and social interaction. These choices produced extraordinary adaptability, but they came at the cost of long-term biological stability. Importantly, animals that age slowly are not better designed. They are designed for different problems. Their biology reflects the demands of their environments, just as human biology reflects ours. Aging, therefore, is not something that some species solved while others failed. It is something that different species address differently, based on what mattered most for survival and reproduction. By viewing aging through this lens, the contrast between humans and other animals becomes less puzzling. Humans die from aging because our evolutionary path did not require us to avoid it. The difference lies not in destiny or superiority, but in the ancient pressures that shaped each body long before modern humans began asking why they grow old. Animals that age slowly or show little visible aging tend to share certain biological patterns, but these patterns are often misunderstood. They are not magic solutions or isolated tricks. They are consistent outcomes of life, strategies that emphasize stability over speed. When we examine these animals carefully, what stands out is not a single extraordinary mechanism, but a collection of modest differences that work together over long periods of time. These differences reflect how energy is managed, how damage is controlled, and how reproduction is timed. One of the most common traits among slowly aging animals is a slower pace of life. Growth tends to be gradual. Development takes longer. Reproduction often begins later compared to species with faster life cycles. This slower tempo reduces metabolic strain. Lower metabolic intensity means fewer byproducts that damage cells and tissues. Over decades, even small reductions in damage accumulation can have large effects. In contrast, humans invest heavily in rapid early development, especially in the brain, which increases metabolic demands and long-term wear. Another shared trait is a strong emphasis on maintenance. Slowly aging species often allocate more energy to repair and regulation rather than rapid performance. Cellular systems responsible for fixing damage, maintaining proteins, and stabilizing internal conditions tend to operate more consistently across the lifespan. This does not mean repair is perfect. It means it remains effective for longer. These species did not evolve perfect bodies. They evolved bodies that maintain acceptable function over extended periods because survival at older ages mattered for reproduction. Reproductive strategy itself also plays a key role. In many slowly aging animals, reproduction is spread out over time rather than concentrated early in life. When reproduction continues into later years, the body has an incentive, from an evolutionary perspective, to remain functional. Traits that preserve health longer are more likely to be passed on. In humans, reproduction historically occurred relatively early, often before significant aging took place. Once reproduction was complete, there was little selective pressure to preserve the body beyond that point. Environmental stability further supports slow aging. Animals that experience low predation and stable resources are less likely to die from sudden external causes. This shifts the balance toward internal reliability. If an animal is likely to survive year after year, internal decline becomes a meaningful threat. Selection can then act on subtle differences in maintenance and repair. Humans did not evolve under such stable conditions. Our ancestors faced unpredictable dangers that made long-term internal perfection less relevant. Importantly, these traits do not operate independently. A slower metabolism supports maintenance. Maintenance supports long-term function. Long-term function supports extended reproduction. Together, they form a coherent strategy. Humans represent a different strategy, one that prioritizes flexibility, intelligence, and early success in uncertain environments. The fact that some animals age slowly does not imply that humans are missing a single crucial feature. It means we followed a different path. Aging patterns emerge from how multiple systems are balanced over time. Slowly, aging species balance them one way, humans balance them another. Understanding this removes the temptation to search for simple explanations or quick fixes. The difference between humans and slowly aging animals is not a secret hidden in one gene or organ. It is the result of long-term trade-offs shaped by environment and history. By recognizing these shared characteristics, we gain a clearer view of why aging varies so widely across life and why the human experience represents just one of many possible outcomes. It is important to recognize the limits of comparison. Humans often look to these species and ask what we might copy or correct in ourselves. This instinct is understandable, but it rests on a misunderstanding of how biology works. Aging patterns cannot be separated from the entire life strategy of an organism. They are not isolated features that can be transferred without consequence. Animals that age slowly do so as part of a broader system shaped by their environment, reproduction, metabolism, and survival risks. Removing one element from that system would not produce the same result in humans. Slowly aging animals often accept constraints that humans would not tolerate. Their growth is slower, their reproductive rate is lower, their energy use is more conservative. These traits make sense in stable environments where survival is predictable and competition is limited. For humans, such constraints would have been costly. Our ancestors survived by expanding into new territories, adapting to changing climates, and cooperating in large social groups. These demands favored speed, flexibility, and learning over patience and long-term stability. Aging patterns are embedded in those choices. This is why it is misleading to imagine that humans simply lack what slowly aging animals possess. We did not lose something they kept. We never evolved under the same pressures. Our bodies reflect a different solution to the problem of survival. Another limitation lies in complexity. The human body, especially the human brain, operates at a high level of integration. Many systems are tightly linked, Changing one aspect of maintenance or metabolism would affect many others. In species with simpler life strategies, adjustments to repair or energy use may carry fewer side effects. In humans, the same changes could disrupt growth, reproduction, cognition, or immune function. Evolution balances these systems through countless small adjustments over long periods. It does not isolate a single trait and optimize it independently. This makes direct comparison not only difficult, but misleading. There is also a tendency to romanticize animals that age slowly, treating them as models of biological success. But every strategy has costs. Slowly aging species often live in narrow ecological niches. They may be less adaptable to rapid change. Their reproductive output may be lower. Their populations may recover more slowly from disruption. Humans traded long-term bodily stability for adaptability and resilience at the species level. Our success as a species came not from individual longevity, but from cooperation, culture, and knowledge passed between generations. Aging, in this sense, is intertwined with what made humans successful. Understanding these limits helps prevent false conclusions. The question is not why humans failed to become like these animals. It is why evolution asked different things of us. Aging patterns reflect those demands. They are not flaws waiting to be corrected, but signatures of the path our species followed. This does not mean aging cannot be studied or mitigated. It means expectations must remain grounded in reality. Any attempt to change aging must reckon with the deep trade-offs that shape the human body. Comparing ourselves to slowly aging animals can illuminate possibilities, but it cannot erase history. Humans die from aging, while some animals do not, because we were shaped for different problems in a different world. That difference is not an error. It is the outcome of ancient pressures that continue to echo through our bodies today. Even when the biology of slowly aging animals is described carefully, a deeper issue remains. Humans often approach these comparisons with the hope that aging is a technical problem, waiting for a borrowed solution. This hope assumes that aging exists as a detachable feature, something that can be isolated, adjusted, or removed without altering the rest of the organism. Evolution does not work this way. Aging patterns are not independent modules. They are inseparable from how an organism grows, reproduces, uses energy, and survives within its environment. Animals that age slowly are not simply protected from decline. They live lives organized around long-term stability rather than rapid performance. Their entire biology reflects this orientation. Growth is slower, reproduction is delayed or spread across time, and energy expenditure is tightly regulated. These traits reduce damage, but they also limit speed, flexibility, and short-term output. For early humans, such limitations would have been dangerous. Survival required quick adaptation, long-distance movement, and intense social learning. A body optimized for patience rather than responsiveness would not have thrived under those conditions. This highlights a critical misunderstanding in how humans interpret biological comparison. We often imagine that our species fell short of an ideal model that other animals achieved. In reality, there is no single ideal. Humans did not fail to evolve slow aging. We evolved something else instead. Intelligence, culture, cooperation, and adaptability became our primary tools for survival. These tools allowed us to reshape environments rather than waiting for stability. The cost of this strategy appears gradually in the body. Aging is not separate from what made humans successful. It is bound to it. Another limit of comparison lies in biological integration. Human physiology is deeply interconnected. Changes to metabolism, repair, or growth influence cognition, immunity, reproduction, and behavior simultaneously. In animals with simpler or more specialized life strategies, adjustments to maintenance may have fewer cascading effects. In humans, even small shifts can ripple across systems. Evolution shaped these balances slowly over immense timescales. There is no straightforward way to adopt one feature from another species without disrupting the broader structure. This is why evolutionary history matters more than isolated mechanisms. It also explains why slowly aging animals often occupy narrow ecological niches. Their strategy works because the environment supports it. Stability allows maintenance to matter. Humans evolved in fluctuating landscapes where adaptability outweighed durability. Our success as a species depended less on individual lifespan and more on the transmission of knowledge across generations. Older individuals contributed through memory, experience, and social structure, even as their bodies declined. In this way, aging did not prevent human survival. It shaped human society. Understanding this reframes the question of comparison. The issue is not why humans lack what other animals possess, but why our path required different priorities. Aging is the long-term consequence of those priorities, not a defect waiting to be corrected by imitation. Recognizing these limits does not deny the value of studying other species. It clarifies what such studies can and cannot promise. They can reveal possibilities, constraints, and trade-offs. They cannot erase the evolutionary context that shaped the human body. Humans die from aging while some animals do not because our bodies were built to solve different problems in a different world, long before longevity became common. That difference is not a mistake. It is a record of where we came from, written quietly into the way we grow old. Living longer is often imagined as a simple extension of life, but from a biological perspective, it carries a cost that cannot be ignored. Every organism must constantly repair itself to remain functional. Cells divide, proteins are replaced, damage is corrected. None of this happens for free. Repair requires energy, time, and resources that could otherwise be used for growth, movement, or reproduction. To live long, an organism must invest heavily in maintenance. To live fast and reproduce early, it must accept gradual deterioration. Humans evolved on the latter side of this balance. The human body performs an extraordinary amount of repair, but it does so only to a point. Repair systems are efficient when we are young, when survival and reproduction depend on them most. This is not because the systems are designed to fail, but because maintaining perfect repair indefinitely would be energetically unsustainable. Evolution favors solutions that are efficient enough, not solutions that are flawless. For early humans, the environment rewarded bodies that could function well during the years when strength, learning, and reproduction mattered most. Investing additional energy into long-term cellular perfection offered little immediate advantage. As a result, repair systems evolved to balance effectiveness with cost. They fix the most dangerous damage quickly, while tolerating smaller errors that accumulate slowly. This accumulation is what we experience as aging. When we compare humans to animals that age slowly, differences in maintenance become clearer. Slowly aging species tend to invest more consistently in repair throughout life. Their cells maintain stability for longer periods. Damage accumulates more slowly, but this investment comes with trade-offs. Growth is slower, reproduction is delayed, energy use is restrained. These strategies make sense only in environments where long-term survival reliably contributes to reproductive success. For humans, such conditions were rare. Our ancestors faced unpredictable dangers that made immediate performance more valuable than long-term preservation. The cost of living long therefore becomes visible only when life is extended beyond its original design window. Modern medicine reduces early death, allowing human bodies to reach ages where accumulated damage becomes dominant. At this stage, repair systems are still active, but they are no longer sufficient to fully counterbalance decades of wear. It means that the balance between damage and maintenance has shifted. Damage arrives faster than it can be perfectly corrected. Aging emerges from this imbalance. Importantly, this imbalance is not unique to humans. It exists in all living systems. The difference lies in how strongly it is managed. Species that evolve to prioritize longevity invest more heavily in maintenance from the start. Humans invested just enough to survive and reproduce under harsh conditions. The result is a body that can be remarkably resilient in early life, yet increasingly vulnerable later on. Understanding aging as a cost of repair reframes the question of why humans die from aging. We do not die because our bodies stop repairing themselves. We die because repair was never meant to outpace damage indefinitely. The energy required to do so would have come at the expense of everything else that once made survival possible. Aging is therefore not the absence of repair, but the visible limit of how much repair evolution could afford. As the years pass, the balance between repair and damage in the human body slowly shifts. This shift is not sudden, and it does not begin at a clearly defined age. It unfolds gradually, often unnoticed, as countless small repairs become slightly less precise than before. Early in life, repair systems are strong enough to keep damage below a critical threshold. Cells replace themselves efficiently. Proteins are renewed before errors accumulate. Tissues recover quickly after stress. This balance allows the body to function with remarkable reliability during the years that mattered most in our evolutionary past. Over time, however, the cost of maintaining this balance increases. Every repair requires energy, coordination, and accurate signaling between cells. As systems grow more complex, perfect maintenance becomes increasingly difficult. Small inefficiencies appear, not because repair mechanisms disappear, but because they must operate continuously under changing conditions. DNA repair becomes slightly less accurate. Protein quality control becomes marginally slower. Cellular cleanup systems leave behind traces of damage that were once removed completely. None of these changes are dramatic on their own. Their significance lies in their accumulation. When small errors persist, they interact. Damage in one system increases stress on another. Reduced efficiency in energy production affects repair capacity elsewhere. Inflammation becomes harder to regulate, adding further strain. This network effect explains why aging accelerates subtly over time. It is not driven by a single failing process, but by the growing difficulty of coordinating many imperfect repairs simultaneously. From an evolutionary perspective, this gradual shift was acceptable. Early humans rarely lived long enough for these cumulative effects to dominate survival. As long as repair systems remained effective through the reproductive years, selection pressure remained weak. Improving long-term repair would have required diverting energy away from growth, immunity, or reproduction, all of which were immediately important. Evolution chose sufficiency over longevity. Modern humans now live long enough to experience the long tail of this choice. We encounter the phase where maintenance struggles to keep pace with decades of accumulated wear. Importantly, this struggle does not imply that the body has stopped trying to repair itself. On the contrary, repair activity often remains high. What changes is the ratio. Damage arrives faster than it can be perfectly resolved. Over time, this imbalance manifests as reduced resilience. Recovery slows. Tolerance for stress decreases. Systems that once compensated for each other lose flexibility. This helps explain why aging feels progressive rather than sudden. There is no moment when the body gives up. Instead, the cost of keeping everything running gradually exceeds what biology can sustain. In species that evolved for longevity, this tipping point is delayed because maintenance investment is higher from the start. In humans, it arrives earlier because our biology was shaped for a different horizon. Understanding this accumulation reframes aging as an economic problem rather than a mechanical failure. The body is constantly managing limited resources. For most of human history, the optimal strategy was to spend generously early and accept slow losses later. Aging is the visible result of that long-term accounting. We die from aging not because repair disappears, but because the cost of perfect repair was never paid in full. Over decades, the unpaid balance grows until the system can no longer absorb it. The idea that aging could be eliminated entirely often assumes that evolution simply failed to invest enough in repair. This assumption overlooks a deeper constraint. Repair does not exist in isolation. It must be coordinated, regulated, and integrated across the entire body. Each additional layer of maintenance adds complexity, and complexity itself carries risk. More repair systems require more signaling, more energy allocation, and more opportunities for imbalance. Evolution does not endlessly add safeguards because each safeguard introduces new points of failure. For humans, increasing repair beyond a certain level would have required redesigning the entire life strategy of the species. That redesign never occurred because it offered no clear advantage under ancestral conditions. To understand why evolution could not simply pay more to eliminate aging, we must consider the limits of biological coordination. The human body contains trillions of cells that must act in synchrony. Repair processes must respond quickly to damage while avoiding excessive activity that could disrupt normal function. Perfect repair would require constant monitoring and intervention at every level. This degree of control would consume enormous energy and demand extreme regulatory precision. Even small errors in such a system could produce catastrophic effects. Evolution favors robust systems that tolerate imperfection rather than fragile systems that demand perfection. Human biology reflects this preference. It relies on repair that is flexible and adaptive, not flawless. Another constraint lies in timing. Repair systems must operate without interfering with growth, reproduction, and immune defense. Enhancing long-term maintenance could slow development, reduce fertility, or weaken early survival. For early humans, these trade-offs would have been unacceptable. Survival depended on reaching adulthood quickly, reproducing successfully, and responding forcefully to immediate threats. Any strategy that compromised these priorities would have been selected against, even if it promised longer life later. Evolution does not optimize for distant benefits at the expense of immediate success. Aging persists because the costs of eliminating it would have undermined the very traits that made humans viable in their original environment. There is also a limit imposed by variability. No two environments are identical, and no organism can predict future conditions. Repair systems that are too rigid may perform well under one set of circumstances but fail under another. Human survival depended on flexibility, on the ability to adjust to changing climates, diets, and social structures. Repair that is good enough across many conditions is more valuable than repair that is perfect under only a few. Aging emerges where this flexibility meets its limits. Over long periods, adaptive systems lose precision, not because they were poorly designed, but because they were designed to handle uncertainty rather than permanence. This perspective helps explain why aging cannot be fully erased without altering what it means to be human. Repair competes with growth. Stability competes with adaptability. Evolution resolved these conflicts in ways that favored survival and reproduction in a dangerous world. The resulting body can endure stress, learn quickly, and cooperate socially, but it cannot maintain perfect order indefinitely. Aging is the visible boundary of that compromise. Understanding this shifts the question from how aging could have been avoided to why it was acceptable. Evolution did not ignore aging because it was harmless. It ignored it because preventing it would have been too costly given the constraints humans faced. Aging remains not because biology failed, but because biology chose a path that prioritized life now over life forever. Human intelligence is often celebrated as our greatest achievement, but from a biological perspective, it came with costs that are easy to overlook. The human brain is not simply another organ. It is one of the most energetically demanding structures in the body. Even at rest, it consumes a disproportionate share of our total energy. During childhood, this demand is even higher as the brain grows, forms connections, and learns to interpret a complex social and physical world. This heavy investment shaped nearly every aspect of human biology, including how we age. Energy devoted to brain development and function is energy that cannot be used elsewhere. Throughout evolution, This trade-off influenced how the rest of the body was built and maintained. Early humans benefited enormously from intelligence. Learning, memory, planning, and communication allowed small groups to survive in unpredictable environments. These abilities reduced immediate threats and improved reproductive success. But they also required a body that could support a large, active brain. To do so, evolution adjusted priorities. Growth patterns changed, childhood lengthened, other systems accepted compromises. Long-term bodily maintenance was one of them. A long childhood illustrates this clearly. Humans mature more slowly than most animals. This extended development allows the brain to absorb culture, language, and social norms. It also delays reproduction and increases vulnerability early in life. Evolution accepted this risk because the payoff was enormous adaptability later on. However, extending development and maintaining a large brain increases cumulative energy use across the lifespan. Higher metabolic activity produces more internal wear over time. The brain itself must be protected at all costs, often at the expense of other tissues. As long as cognitive function supports survival and reproduction, gradual physical decline elsewhere remains tolerable from an evolutionary standpoint. The brain's dominance also reshaped the human body structurally. Upright posture, fine motor control, and complex speech required precise coordination between neural and muscular systems. This precision works best when young, when repair and adaptation are rapid. Over decades, however, maintaining such coordination becomes increasingly difficult. Small inefficiencies accumulate, reaction times slow, balance becomes harder to maintain. These changes are not isolated failures. They are the long-term cost of operating a highly integrated system optimized for performance rather than durability. Another important factor is resource allocation. The brain competes with other organs for nutrients, oxygen, and energy. During stress, the body prioritizes brain function. This hierarchy makes sense for survival, but can accelerate decline elsewhere. Organs and tissues that are less critical for immediate decision-making receive less investment over time. Aging reflects this imbalance. The body preserves what matters most for cognition and social function for as long as possible, while other systems gradually lose resilience. From an evolutionary perspective, this strategy was successful. Human survival did not depend on perfect physical condition late in life. It depended on knowledge, memory, and cooperation. Older individuals contributed through experience and guidance, even as their bodies weakened. Intelligence allowed humans to shift part of survival from biology to culture. Tools, shared knowledge, and social structures compensated for physical decline. Aging bodies became acceptable because wisdom and memory extended influence beyond strength. This does not mean intelligence directly causes aging. It means that the evolutionary commitment to intelligence altered the balance of investment across the body. Resources were concentrated where they produced the greatest immediate benefit. Long-term physical maintenance became secondary. When modern humans live long enough, this imbalance becomes visible as aging. Understanding this helps explain why human aging cannot be separated from human intelligence. The same traits that allowed us to thrive also shape the limits of our bodies. Aging is not the price of failure. It is part of the cost of becoming the kind of species that thinks, remembers, and passes knowledge forward across generations. As human intelligence reshaped the body's priorities, it also changed how aging unfolds across the lifespan. The brain does not simply demand energy during growth. It continues to require constant support throughout life. Neurons must maintain precise connections. Chemical signals must remain balanced. Blood flow and oxygen delivery must be tightly regulated. Preserving cognitive function is biologically expensive, and this expense influences how the rest of the body is maintained over time. Evolution favored strategies that protected mental capacity even as physical systems gradually lost strength. This preference altered the pattern of aging in subtle but important ways. In early and middle adulthood, the body works to preserve speed of thought, memory, and coordination, because these abilities directly affect survival and social contribution. Physical decline may begin quietly, but it does not immediately threaten reproductive success or group survival. As long as individuals can think clearly, communicate, and participate socially, gradual physical weakening remains tolerable from an evolutionary perspective. This helps explain why many aspects of aging first appear as changes in stamina, recovery, and musculoskeletal resilience rather than sudden cognitive collapse. The body gives up physical margin before it sacrifices mental function. Over time, however, maintaining this balance becomes increasingly difficult. The systems that support the brain rely on the health of the entire body. Circulation, metabolism, immune regulation, and hormonal signaling all contribute. As these systems experience accumulated wear, the effort required to preserve cognitive stability rises. More resources are diverted to maintenance, leaving less available for repair elsewhere. This redistribution accelerates decline in peripheral tissues. Muscles weaken faster, bones lose density, organs recover more slowly. Aging, in this sense, reflects the body's attempt to preserve what evolution valued most for as long as possible. There is also a social dimension to this trade-off. Human survival became increasingly dependent on cooperation rather than individual physical dominance. Knowledge, language, and shared memory allowed groups to function even when some members were physically compromised. Older individuals contributed through teaching, planning, and cultural continuity. This reduced the selective pressure to maintain peak physical performance late in life. The value of an aging individual shifted from strength to experience. Evolution responded accordingly, favoring bodies that could support cognitive engagement longer, even if physical capacity declined. This shift created a unique aging profile. Humans often remain mentally engaged well into later life, even as their bodies change. This pattern is not universal across species. It reflects a life strategy in which intelligence and social structure buffer the consequences of physical aging. But this buffering has limits. Eventually, the cumulative cost of maintaining brain function strains the entire system. When coordination between systems weakens beyond a certain point, cognitive decline may follow. This sequence reinforces the idea that aging is not driven by a single cause. It emerges from how priorities are set and maintained over time. Intelligence did not eliminate aging. It reshaped it. By concentrating resources on cognition and social function, human evolution allowed physical decline to proceed gradually and unevenly. This arrangement worked remarkably well in ancestral environments. It allowed groups to benefit from experience, while younger members provided physical labor. In modern times, extended lifespans expose the long-term consequences of this strategy. We now live long enough to see the full arc of the trade-offs that intelligence imposed on the body. Aging becomes visible not as a failure of the brain, but as the cost of sustaining it for decades beyond the conditions that shaped it. Eventually, the strategy that prioritizes intelligence over physical durability reaches its biological limits. The human brain, despite its flexibility and resilience, is still part of the same aging system as the rest of the body. It cannot be fully insulated from long-term decline. The longer life extends, the more demanding it becomes to preserve the delicate balance required for stable cognition. Neurons depend on constant energy supply, precise chemical regulation, and effective waste removal. These processes are supported by organs and systems that themselves age. As coordination between systems weakens, the cost of maintaining mental function rises sharply. Intelligence allowed humans to shift survival away from pure physical strength, but it did not remove the constraints of biology. The brain's complexity makes it powerful, but also vulnerable. Small disruptions that would be manageable in simpler organisms can have widespread effects in humans. Over decades, minor inefficiencies in circulation, metabolism. This is why cognitive aging often appears later than physical decline, but progresses once it begins. The system resists change for a long time, then becomes harder to stabilize. From an evolutionary perspective, this pattern was acceptable. Selection favored brains that could support learning, memory, and cooperation during the years that mattered most for group survival. There was little pressure to ensure flawless cognition far beyond that period. Evolution did not need to guarantee permanent clarity. It needed sufficient function to sustain culture across generations. Once that condition was met, further protection offered diminishing returns. Modern humans now encounter this boundary more frequently because we live far longer than our ancestors did. Extended lifespans expose the full cost of sustaining complex cognition over many decades. What once appeared as rare decline becomes common experience. This can create the impression that intelligence itself carries a hidden flaw. In reality, the flaw lies not in intelligence, but in expecting a system optimized for adaptation and learning to maintain perfect stability indefinitely. Aging reveals the limits of complexity. The more intricate a system becomes, the more energy and coordination it requires to preserve order. Human intelligence pushed biological organization to remarkable heights, but it also narrowed the margin for error over time. Understanding this completes the picture of how intelligence fits into human aging. It was not a cure for biological limits. It was a different way of managing them. By relying on culture, cooperation, and shared memory, humans reduced the need for long-lasting bodies. Aging became acceptable because meaning and contribution could persist even as physical and cognitive capacities changed. This perspective reframes the relationship between aging and the mind. Cognitive decline is not evidence that intelligence failed. It is evidence that intelligence was never meant to stand alone, indefinitely supported by biology. It was meant to operate within a network of social and cultural continuity that outlived any single body. Aging marks the point where individual biology yields to collective legacy, closing one chapter so that knowledge and experience can continue through others. Modern society often treats aging as a problem to be solved, but this perception emerges only when the social environment changes faster than biology can follow. For most of human history, social structures masked the limits of the aging body. Survival depended on group cooperation, shared labor, and intergenerational roles. Individuals were rarely judged by their physical independence alone. As long as a person could contribute knowledge, coordination, or decision-making, gradual physical decline did not remove their value. Aging existed, but it was integrated into social life rather than highlighted as a personal failure. This balance began to shift as human societies became more complex and specialized. Agriculture, urbanization, and later industrialization transformed how survival was organized. Physical labor became separated from knowledge. Productivity became measurable. Roles became narrower. In this new context, aging bodies became more visible. Decline was no longer absorbed quietly by communal structure. It stood out against expectations of consistency and efficiency. This shift did not change human biology. It changed how aging was experienced and interpreted. The body did what it had always done, but society began to demand more from it for longer periods. As social systems evolved, they reduced many of the external risks that once ended lives early. Food became more stable. Shelter improved. Medical practices reduced death from infection and injury. These changes extended life, but they also exposed the long-term limits of human physiology. Aging moved from the background to the foreground. What was once a gradual, often unseen process became the primary cause of decline. This visibility reshaped attitudes. Aging began to feel abnormal, even though it was not new. The modern individual often experiences aging in isolation, rather than as part of a shared rhythm of life. This isolation amplifies its psychological weight. When societies emphasize independence, speed, and continuous output, aging becomes harder to integrate. From an evolutionary perspective, this framing is misleading. Human aging did not suddenly worsen. The context around it changed. Social systems that once buffered physical decline have been replaced by structures that highlight it. This creates the impression that aging itself is the enemy. In reality, aging has always been present. What has changed is how much room society gives it. Understanding this distinction helps clarify why aging feels more threatening in modern life. It is not because the body has become weaker, but because social expectations have become less forgiving. Humans evolved to age within communities that adapted around changing capacities. When those adaptations disappear, aging becomes more visible and more difficult to bear. This perspective shifts the question away from biology alone. It invites us to consider how social organization shapes the experience of aging, turning a natural process into a perceived crisis. Aging, in this light, is not just a biological event, it is a social mirror, reflecting the values and structures of the world in which it unfolds. As social organization continued to change, medicine and technology began to play a decisive role in how aging was revealed. Modern healthcare dramatically reduced deaths from causes that once ended lives early. Infections that were once fatal became treatable. Injuries that would have disabled or killed could now be managed. Chronic conditions could be controlled rather than immediately life-ending. These advances extended human lifespan, but they did so without altering the underlying biology that shaped aging. Medicine removed the external pressures that once concealed long-term decline, allowing the internal limits of the body to surface more clearly. The more successful medicine became at preserving life, the more visible aging itself became. In earlier eras, people often died with aging rather than from aging. Decline existed, but it was rarely the primary cause of death. Modern medicine changed this balance. By preventing early death, it shifted the burden of mortality onto processes that unfold slowly over time. Aging moved from a background condition to the central challenge. This shift can distort perception. It may appear that humans are now aging more severely than before. Medical intervention also altered expectations. Survival became something that could be actively managed. As a result, decline began to feel optional, even though biology had not changed. This gap between expectation and reality fuels frustration. When technology solves many problems, the ones it cannot solve stand out more sharply. Aging becomes conspicuous precisely because so much else has been controlled. From an evolutionary perspective, this situation is unprecedented. Human biology evolved under conditions where medicine did not exist. There was no selective pressure to build bodies that could remain fully functional for many decades after reproduction. Modern healthcare exposes this mismatch. It sustains life beyond the window that shaped our physiology, revealing vulnerabilities that were once rarely encountered. Importantly, medicine does not cause aging. It reveals it. The limits we observe today were always present, embedded in a body optimized for survival under different conditions. This revelation also changes how individuals experience aging. Medical monitoring makes decline measurable. Numbers, scans, and diagnoses turn gradual change into explicit information. What was once felt slowly is now documented precisely. This can intensify the sense of loss, even when function remains adequate. Aging becomes something to track rather than something to live with. Social narratives reinforce this focus, framing health as a continuous project rather than a shifting balance. Understanding this context helps reframe the role of medicine. Its success does not mean it failed to defeat aging. It means it succeeded in removing everything else that once hid it. Aging now stands exposed, not because it has grown stronger, but because the world around the body has changed. This recognition prepares the ground for a deeper question. If aging is revealed rather than created by modern society and medicine, then the challenge is not simply how to eliminate it, but how to live meaningfully with a body whose limits are now impossible to ignore. As aging becomes more visible through modern society and medicine, a deeper shift occurs in how humans understand themselves. The body is no longer seen simply as something that lives and changes, but as something that should be managed, optimized, and maintained indefinitely. This expectation creates tension. Biology operates through balance and compromise, while modern culture often promises control and permanence. Aging exposes the gap between these two ways of thinking. When decline appears despite effort, it can feel like failure, even though it is a normal outcome of how the human body was shaped. This psychological shift changes the meaning of aging. Instead of being a shared stage of life, it becomes an individual burden. People are encouraged to remain productive, independent, and efficient for as long as possible. When the body can no longer meet these standards, aging is framed as loss rather than transition. From an evolutionary perspective, this framing is new. Humans evolved in groups where roles changed naturally with age. Physical strength declined, but social value did not disappear. Experience, judgment, and memory remained essential. Modern structures often separate these contributions from daily life, narrowing the space in which aging can be integrated meaningfully. This separation intensifies the sense that aging is something to resist rather than understand. There is also a moral dimension to this shift. When health is treated as a personal achievement, decline can be interpreted as personal failure. This ignores the biological reality that aging reflects limits set long before individual choice existed. No amount of discipline can fully override evolutionary trade-offs. Expecting the body to perform indefinitely under modern standards creates unrealistic pressure. Aging then becomes not just a biological process, but a source of anxiety and self-judgment. Understanding this helps restore perspective. Aging did not suddenly become worse. It became more visible, more measured, and more isolated. The body still follows the same patterns shaped by ancient environments. What has changed is how society responds to those patterns. Recognizing this does not remove the physical challenges of aging, but it changes how they are interpreted. Instead of seeing aging as a defect to be corrected, it can be seen as a signal that the body has reached the edge of its evolutionary design. This recognition opens space for a different response. Rather than demanding endless performance, societies can adapt roles, expectations, and values to changing capacities. Such adaptation aligns more closely with how humans lived for most of their history. Aging then becomes part of continuity rather than a breakdown. This perspective completes the social arc of aging. Biology sets limits, medicine reveals them, and society decides how they are lived. Humans die from aging, not only because bodies decline, but because the world around those bodies struggles to accommodate that decline. How aging is experienced depends as much on social meaning as on cellular change. Understanding this prepares the way for the final question of the series. Not how to escape aging, but what kind of life remains possible, valuable, and human once its presence can no longer be ignored. Slowed or reversed, they often turn toward modern science for answers. Biology, medicine, and technology promise understanding at a level never before possible. Cells can be observed, genes can be mapped, and molecular processes can be measured in detail. This unprecedented access creates the impression that aging is now a technical problem, one that might yield to sufficient knowledge and intervention. Yet this view risks misunderstanding what science can reveal and what it can change. Scientific insight exposes mechanisms, but it does not erase the evolutionary context that produced them. Aging becomes visible under the microscope, but visibility does not imply removability. Modern research has identified many processes associated with aging: gradual accumulation of cellular damage, reduced efficiency of repair, changes in communication between cells, and shifts in metabolism and immune regulation. They clarify how aging unfolds inside the body. However, they do not point to a single cause that can be isolated and removed. Aging appears instead as a pattern emerging from many interacting systems, each shaped by evolutionary trade-offs. Science reveals complexity rather than simplicity. This creates a second paradox. The more precisely aging is studied, the clearer its distributed nature becomes. Intervening in one process often affects many others. Improving one aspect of repair may increase stress elsewhere. Enhancing cellular longevity may raise the risk of malfunction or uncontrolled growth. The body operates as a negotiated balance, not a collection of independent parts. Science can shift this balance, but it cannot redesign it without consequences. This limitation is not a failure of research. It reflects the fact that human biology was not assembled with long-term optimization in mind. The systems science observes today are the outcome of ancient solutions to survival problems that no longer exist. Medicine can extend life, reduce suffering, and manage decline, but it does so by working within the constraints of that inherited design. It does not rewrite it. This distinction matters because it shapes expectations. When aging is framed as a problem science should eliminate, every limit feels like disappointment. When aging is understood as a boundary science can clarify but not fully remove, its role becomes different. Knowledge becomes a tool for adaptation rather than conquest. Understanding the mechanisms of aging allows humans to live more comfortably within their limits, even if those limits remain. This perspective also helps explain why progress against aging feels incremental rather than revolutionary. Advances arrive as improvements in quality of life, not as escapes from mortality. Science refines the experience of aging rather than abolishing it. In doing so, it exposes the deep continuity between modern humans and their ancestors. Despite technology and knowledge, the body still follows pathways shaped long before laboratories existed. Aging reminds us that scientific understanding operates inside biology, not above it. Recognizing this prepares the ground for a more grounded question. If science cannot erase aging, but can reveal its structure and ease its burdens, then the challenge shifts. The question becomes not how to defeat aging. As scientific understanding deepens, another tension becomes clear. Knowledge about aging grows faster than the ability to act on it, without unintended consequences. Modern biology can describe processes in extraordinary detail, but intervening safely in those processes is far more difficult. Aging does not arise from a single malfunction. It emerges from interactions among repair systems, metabolism, immune regulation, and cellular communication. When one element is altered, the balance of the entire system shifts. This is why many interventions that appear promising in theory produce limited or mixed results in practice. Slowing one aspect of aging may accelerate another. Enhancing repair in one tissue may increase instability elsewhere. Science reveals not a switch to turn off, but a network that resists simple control. This resistance reflects the evolutionary history of the human body. The systems that govern aging evolved to function reliably under uncertainty, not to be precisely tuned for long-term stability. They are robust, but not finely optimized. Robust systems tolerate variation and damage, but they also resist precise manipulation. When modern interventions attempt to push these systems beyond their evolved range, unexpected effects often appear. This does not mean intervention is futile. It means intervention must remain cautious, incremental, and aware of trade-offs. Much of modern progress against aging therefore takes the form of management rather than elimination. Diseases associated with aging are treated individually. Symptoms are reduced. Function is preserved for longer periods. These achievements matter. They improve daily life and extend years of relative independence. Aging continues because the foundational balance between damage and maintenance remains. Science can influence the slope of decline, but not erase it entirely. This reality often clashes with public expectation. Breakthroughs are anticipated. Singular cures are hoped for. When they do not arrive, disappointment follows. Yet this expectation misunderstands what aging represents. Aging is not a foreign invader that science can defeat. It is the long-term expression of how the body was assembled. Each scientific advance clarifies this truth rather than overturning it. The value of research lies in illumination, not illusion. Understanding limits is itself a form of progress. It allows realistic goals to replace impossible ones. Instead of seeking escape from aging, science can help individuals navigate it more gently. It can reduce suffering, extend function, and support dignity. These outcomes may appear modest compared to dreams of reversal. As humans confront the full visibility of aging, the role of science becomes less about conquest and more about stewardship. Knowledge becomes a way to care for a body that cannot be made permanent, but can be supported wisely. This shift prepares the ground for a deeper reflection. When control reaches its limits, meaning becomes more important than mastery. Understanding how far science can go invites a reconsideration of what it means to live well within unavoidable constraints, rather than endlessly struggling against them. As scientific ambition meets biological reality, a final realization emerges. Aging persists not because humans lack intelligence or technology, but because the body represents a history that cannot be undone without altering what it is. Every discovery about aging reinforces this continuity. The mechanisms science uncovers today are not errors waiting to be corrected. They are consequences of systems shaped to survive, adapt, and reproduce under ancient constraints. Modern knowledge illuminates these systems, but illumination does not dissolve origin. The body remains a record of its past. This realization changes the meaning of progress. Instead of imagining a future free from aging, science increasingly points toward a future shaped by informed accommodation. Understanding how aging unfolds allows humans to anticipate its effects, reduce unnecessary suffering, and preserve function where possible. But it also clarifies where limits remain firm. Attempting to push beyond those limits risks destabilizing the very systems that support life. Biology tolerates adjustment, not reinvention. Aging becomes the boundary that marks how far adjustment can go before coherence is lost. This boundary is not arbitrary. It reflects the interconnected nature of living systems. Repair, growth, immunity, and metabolism evolve together. Changing one alters the balance of all. Science can shift emphasis, slow decline, or extend resilience, but it cannot isolate longevity from the rest of life. Longevity is not a standalone feature. It is the outcome of an entire life strategy. Humans inherited a strategy that favored adaptability and intelligence over permanence. Science cannot reverse that inheritance without rewriting the conditions that made humans human. Recognizing this does not diminish the value of scientific effort. On the contrary, it grounds it. When expectations align with reality, progress becomes more humane. Research focuses on supporting quality of life, maintaining autonomy, and easing transitions rather than chasing impossible escape. Aging, then, becomes less an adversary and more a terrain to be understood. Knowledge guides navigation rather than conquest. This perspective also reconnects science with humility. Understanding the limits of intervention reveals the depth of biological wisdom embedded in evolution. Systems that endured uncertainty for millions of years cannot be overridden casually. They demand respect as much as curiosity. Aging stands as a reminder that life is shaped by compromise, not perfection. Science's role is not to erase that truth, but to help humans live thoughtfully within it. As this truth concludes, the focus shifts away from mechanisms and interventions toward meaning. When aging cannot be eliminated, its presence invites reflection. The question is no longer how to defeat time, but how to use understanding to live well within time. This transition prepares the way for the final stages of the journey, where biology, society, and individual life converge into a broader reflection on value, continuity, and what it means to remain human in the face of inevitable change. When the biological and scientific explanations are set aside, aging reveals another dimension that cannot be measured in cells or molecules. It reshapes how value is distributed across a human life. In early adulthood, value is often tied to strength, speed, productivity, and independence. These qualities align well with a body operating near its peak. As aging progresses, these metrics gradually lose relevance. Physical capacity changes, reaction slows, and endurance declines. If value remains defined only by performance, aging appears as pure loss. But this interpretation is not inevitable. It reflects a narrow framework that emerged relatively late in human history. For most of our past, value was not concentrated solely in physical output. Aging bodies carried experiences that younger bodies did not yet possess: knowledge of landscapes, social dynamics, conflict resolution, and survival strategies accumulated over time. They required presence, memory, and perspective. Aging, in this context, did not erase usefulness. It transformed it. From an evolutionary standpoint, this transformation mattered. Groups that retained and respected older members gained access to long-term knowledge. Patterns could be recognized. Mistakes could be avoided. Social cohesion could be maintained. Even as bodies weakened, the role of the individual shifted rather than disappeared. Aging became part of a functional cycle rather than an endpoint. This is why aging persisted without being selected against. It did not undermine group survival. It supported it in ways that raw physical strength alone could not. Modern societies often struggle to integrate this shift. When systems reward speed and efficiency above all else, slower contributions become harder to recognize. Aging individuals may feel disconnected from their earlier sources of meaning. This disconnection amplifies the sense that aging is only decline. But this is a cultural interpretation layered on top of a biological process. Biology did not remove value with age. Social frameworks did. Understanding this distinction opens space for a different relationship with aging. Instead of asking how to preserve youth indefinitely, the question becomes how to preserve meaning as capacities change. Aging does not need to signal irrelevance. It can signal transition. The body changes. It shifts toward reflection, guidance, and continuity. Recognizing this does not deny the challenges of aging. Physical discomfort, loss, and vulnerability are real. But meaning is not dependent on physical perfection. Humans evolved as social beings whose survival depended on shared roles across the lifespan. Aging fits within that design. It becomes problematic only when societies fail to adapt roles to changing capacities. This perspective reframes aging not as a theft of value, but as a redistribution of it. What is lost in strength may be gained in depth. What is lost in speed may be gained in clarity. Aging then becomes less about diminishing returns and more about changing contributions. This understanding prepares the way for the final reflection. If aging transforms value rather than destroys it, then the end of life is not merely biological decline. It is the closing phase of a long process of accumulation, where meaning shifts from what the body can do to what the life has carried forward. As life advances toward its later stages, meaning becomes less about accumulation and more about integration. Earlier in life, value is often created by adding experiences, skills, possessions, and achievements. Aging gradually shifts this orientation. The emphasis moves from acquiring new things to making sense of what already exists. Memory, reflection, and coherence take on greater importance. This shift is not a cultural invention. It follows naturally from the way human lives unfold over time. As physical energy declines, attention turns inward, toward understanding patterns, relationships, and consequences that were not visible before. From an evolutionary point of view, this integrative role served an important function. Human groups benefited not only from innovation, but from interpretation. New ideas required context. Past experiences needed to be remembered and compared. Older individuals provided continuity. They connected present decisions to long-term outcomes. This function did not require physical strength. It required time, memory, and perspective. Aging bodies carried stories, lessons, and warnings that could not be learned quickly. In this way, later life contributed to group stability even as individual vulnerability increased. Modern life often disrupts this process. Rapid change reduces the perceived relevance of long-term experience. Technologies evolve faster than memory can be applied. As a result, aging may feel like detachment rather than integration. But this feeling reflects social speed, not biological failure. The human capacity for meaning does not disappear with physical decline. It changes its focus. Events that once felt isolated begin to form a narrative. Choices reveal their consequences. Relationships gain depth. This integrative process can bring clarity, even as other capacities fade. Importantly, this does not romanticize aging. Loss is real. Pain, limitation, and dependency cannot be ignored. But meaning does not require comfort. It requires connection between experiences. Aging provides the temporal distance necessary for such connection. What once felt urgent becomes contextual. What once felt overwhelming becomes understandable. This shift can support emotional stability even as the body weakens. From this perspective, aging is not simply something that happens to a person, it is something that allows a life to become legible. Without time, experience remains fragmented. Aging gathers fragments into a whole. This function cannot be rushed. It depends on duration. It depends on having lived long enough for patterns to emerge. In this sense, aging offers something youth cannot. It offers perspective earned rather than imagined. When societies fail to recognize this role, aging feels empty. When they recognize it, aging becomes a stage of contribution rather than withdrawal. The challenge, then, is not to deny the physical realities of aging, but to support the conditions under which integration can occur. This includes time, attention, and social space for reflection. Aging individuals need not be preserved as relics of the past. They can be engaged as interpreters of it. Understanding this reframes the later stages of life. They are not merely the fading of capacity, but the consolidation of meaning. Aging becomes the process through which a human life moves from action to understanding. This prepares the ground for the final reflection. If aging gathers meaning rather than erasing it, then the end of life is not only an ending, it is the point at which the full shape of a life becomes visible, ready to be carried forward by others. As the end of life approaches, aging reveals its final function, closure. Not closure in the sense of completion without loss, but closure as coherence. A human life does not simply stop, it resolves. Experiences that once felt unfinished gradually lose urgency. Identity shifts from becoming to being. The question is no longer what can still be achieved, but what has been understood. This transition is subtle and often overlooked, yet it reflects a deep alignment between biology and meaning. The slowing of the body creates space for evaluation. Attention narrows. Priorities simplify. What once demanded constant effort begins to release its hold. Younger members carried the future through action and exploration. Older members carried the past through understanding and acceptance. The cycle required both. Aging prepared individuals to let go without destabilizing the group. This capacity to relinquish control reduced conflict, eased transitions, and allowed continuity beyond any single life. Modern culture often resists this function. It frames aging as something to fight until the end, equating value with persistence of performance. When decline becomes undeniable, this framing leaves little room for dignity. Yet biology suggests a different pattern. The body slows not only because systems wear down, but because relentless engagement is no longer necessary. It offers a different kind of contribution: consent to continuity. Accepting limits allows others to step forward. Knowledge is passed on. Responsibility shifts. The individual life yields space to the collective story. This is not resignation. It is participation in a process larger than oneself. Understanding this reframes death itself. It is the end point of a trajectory that has already shifted its focus from accumulation to integration, from effort to understanding. Aging prepares the mind and body for this transition gradually, not abruptly. Fear often arises when this preparation is misunderstood. When aging is seen only as loss, death appears as theft. When aging is seen as resolution, death appears as closure. This does not remove grief or pain, but it changes their context. Loss becomes part of transmission rather than erasure. What remains is not the body, but the influence it carried. Stories, values, lessons, and relationships persist beyond the individual lifespan. Aging made room for this persistence by loosening attachment to immediacy. In this way, aging serves a final purpose that science cannot replace and society cannot accelerate. It transforms a biological endpoint into a human passage. Understanding this completes the arc of meaning. Humans die from aging not only because bodies decline, but because lives reach a point where continuation is no longer the primary task. What matters then is not extension, but completion. Aging guides that completion quietly, allowing a life to finish not as a failure of biology, but as a fulfilled trajectory within the long continuity of human existence. As the journey reaches its final stage, the question of aging no longer belongs to biology alone. It becomes a question about orientation. Throughout this exploration, we have seen that humans die from aging not because of a single flaw, but because of a long chain of evolutionary decisions, biological trade-offs, and social transformations. At this point, the focus shifts from explanation to reflection. What does it mean to live in a body that was never designed for permanence, in a world that increasingly expects it? Aging exposes a quiet tension between what the body can offer and what the modern mind demands. The body follows ancient rhythms. It weakens, slows, and eventually fails. The mind, shaped by culture and expectation, often resists this reality. We plan, project, and imagine continuity far beyond what biology can sustain. This mismatch creates suffering not because aging is cruel, but because expectation is misaligned. Understanding aging reframes this tension. When the limits of the body are recognized as inherited rather than accidental, the struggle changes character. Aging stops being a personal injustice and becomes a shared condition. Every human body carries the same history, shaped by the same constraints. This recognition can soften resistance. It does not remove pain or loss, but it places them within a larger context. Life was never meant to be endless. It was meant to be meaningful within limits. From an evolutionary perspective, limits are not defects. They are boundaries that shape behavior, cooperation, and continuity. Mortality creates urgency. Aging creates transition. Together, they organize the flow of generations. Without them, there would be no renewal, no space for adaptation, no passage of responsibility. The body ages so that life can move forward collectively, even as individual lives conclude. Modern society often attempts to suspend this flow, to hold individuals in place indefinitely, but doing so creates friction. Aging reminds us that belonging to a species means participating in cycles larger than oneself. The question then becomes, not how to escape aging, but how to inhabit it wisely. Wisdom, in this sense, is not resignation. It is alignment. It is recognizing when effort serves growth and when acceptance serves continuity. Aging teaches this lesson gradually, through changes that cannot be rushed or reversed. The final stage of this journey does not offer a solution. It offers a reframing. Humans die from aging, while some animals do not, because our lives were shaped to carry meaning through time, not to remain fixed within it. Aging marks the point where individual striving gives way to shared legacy. In that transition, the body yields, but the human story continues. As the final reflection deepens, aging reveals itself not as an interruption of life, but as one of its organizing forces. Much of human anxiety around aging comes from treating life as a project that should remain open-ended. Goals are set as if time were unlimited. Identity is built around continuity of ability. When aging disrupts this continuity, it feels like a betrayal. Yet from a broader perspective, limitation is what gives structure to meaning. Without boundaries, actions lose weight. Without endings, beginnings lose urgency. Aging introduces finitude gradually, allowing adjustment rather than shock. It teaches, slowly and often unwillingly, that not everything can be carried forward unchanged. This lesson is difficult, but it is not accidental. It reflects how human lives were shaped to unfold. In early life, energy is abundant and directed outward. Exploration, construction, and expansion dominate. In later life, energy contracts. Attention turns towards selection, simplification, and prioritization. Aging narrows the field so that what remains can be held more clearly. This narrowing is often mistaken for loss alone, but it also produces focus. When time feels limited, choices acquire depth, relationships gain clarity. What truly matters becomes easier to see. From an evolutionary and cultural perspective, this transition served an important role. Societies depend not only on growth, but on discernment. Not every possibility should be pursued. Not every impulse should be acted upon. Older individuals, shaped by experience and tempered by limitation, contributed judgment rather than expansion. Aging supported this shift by reducing the constant pressure to act. The body slowed so the mind could weigh. In modern life, where speed is rewarded at all ages, this role is harder to inhabit. Slowing feels like falling behind rather than moving into a different function. But this feeling reflects social values, not biological error. It changes its form. The difficulty arises when societies fail to create space for that change. When worth is tied exclusively to productivity, aging becomes humiliating. When worth is tied to insight, continuity, and care, understanding this helps restore dignity to a process that is often framed only in terms of decline. Aging is not the opposite of living. It is the phase in which living becomes selective, reflective, and relational rather than expansive. It invites a different kind of participation in the human story, one that emphasizes transmission over accumulation, presence over performance, continuity over control. This perspective does not deny fear or grief, but it situates those emotions within a process that has always been part of human existence. Aging prepares individuals to release what cannot be held forever, making room for others to step forward. In doing so, it preserves movement within the species. Life continues not by resisting change, but by yielding to it at the right moment. This understanding brings the question of aging to its ethical core. The challenge is not to defeat aging, but to meet it without confusion, to recognize when effort becomes resistance and when acceptance becomes wisdom. Aging teaches this distinction slowly, across decades, asking not for heroism, but for alignment with the limits that give life its shape. The question that guided the entire journey no longer asks for an explanation. It asks for orientation. Humans die from aging, while some animals do not. Not because something went wrong, but because our lives were shaped around limits rather than permanence. Aging was never an enemy hidden in the body. It was a condition that allowed human life to unfold with rhythm, transition, and continuity. When we follow that rhythm to its end, a different understanding emerges. Life was not designed to be held forever. It was designed to be lived fully within a finite frame. Aging makes that frame visible. It narrows possibilities so that choices gain meaning. It slows the body so that attention can deepen. It loosens attachment so that what remains can be carried forward by others. From this perspective, aging is not the opposite of vitality. It is its completion. Each stage gives way to the next, not as a failure, but as a handoff. Strength gives way to experience. Expansion gives way to discernment. Control gives way to acceptance. These transitions were not accidents. They were woven into how human lives could persist across generations. Without aging, there would be no space for renewal, no opening for the next life to step into responsibility. Modern thinking often treats death as the ultimate problem and aging as the path toward it. But this framing misses something essential. Death is not simply the end of a biological process. It is the boundary that allows life to have shape. Without an end, beginnings lose their weight. Without limits, meaning dissolves into endless extension. Aging prepares the human mind for this truth gradually, not abruptly. It teaches, over decades, that holding on is not the same as living well. Letting go, when it comes, is not defeat. It is participation in something larger than a single body. This understanding does not remove sadness or fear. Those emotions are part of caring deeply about life, but it places them within a wider context. Humans have always lived knowing, at some level, that time is limited. Aging is how that knowledge enters the body, gently but persistently. It invites a different measure of success, not how long life can be extended, but how well it can be lived within its limits. Not how much can be accumulated, but what can be transmitted. Not how tightly control can be held, but how gracefully it can be released. When seen this way, aging is no longer a malfunction to be corrected. It is a teacher that cannot be replaced by science, technology, or denial. It reminds us that life is not owned. It is borrowed, shaped, and passed on. Humans die from aging because our lives were never meant to stop the flow of time, only to move meaning through it. And as this reflection comes to rest, the final question remains open, without an answer to be given. If aging is not something to escape, but something to understand, then what does it mean to live a life that is complete rather than endless?